All right. In the table below, we already saw this table. Here it is again. We have measured dissociation constants for various combinations of FGF ligands and their receptors. ND means not detectable, and we're going to let KD be equal to 10 to the negative fourth. Okay? So the question is, what is the specificity of FGF1 versus FGF5 if the primary target is receptor FGFR2C? Let ligand concentration be 10 to the negative 7th molar for both ligands, and let all receptors be at the same concentration, use 1 molar. Okay. So first of all, why is FGFR2C, this one here, why is this the primary target for both of these? So let's look at FGF1 first. It has the lowest KD. It is the highest affinity, thus it is the primary target. And then it happens to be the exact same thing is true for FGF5. Okay? So right now, before we do any math, what do I think the specificity factor will be for 1 when I compare it across all the receptors for FGF1 versus 5 when I compare it across all of the factors for FGF1? Which is going to have a higher alpha? Does FGF1 bind to other stuff? Does FGF5 bind to other stuff? Not really. I expect right now, before I do anything, that the alpha here, when I compare it across all of the receptors, is going to be much more specific and a higher alpha for FGF5 than FGF1. And what it's asking you to do is essentially solve specificity factor alpha for 1, for 5, and look at those two. So, I know I've taken your numbers away, but we have alpha for FGF1 versus FGF5, both for their primary target FGF receptor 2C. It said to go ahead and assume that ligand concentration was 10 to the negative 7th molar for both. And then it said to let R for all your receptors, all your R total concentrations be 1 molar. Okay. So alpha for FGF1 is going to be equal to, I can't use the very first one that we wrote down that had the concentration of complexed receptor to ligand because I don't have that information, okay? But I can use this version here where it was concentration of R naught total over 1 plus the KD for my primary target over the concentration of ligand over, I can sum up on I equals 1 to n, all my off targets, total concentration of off targets divided by 1 plus the KDs for my off targets, which I'm going to get them all from the table. This is given to me. Okay. So for FGF1, what this ends up looking like is on the top, I have 1 molar for all my receptor concentrations are 1 molar over 1 plus, from the table, the primary receptor was 0.94 times 10 to the negative 7th. I think it's written as 9.4 times 10 to the negative 8th in the table. Divided by, let all the ligand concentrations be 10 to the negative 7th. All over. And like I said, K sub D doesn't really have units. We consider it molar. This is also molar. I will tell you right now, it should all drop out, and you should be unitless for specificity factor. Okay. And then on the bottom, we have all our other receptors. Okay, so I put this one on the top. We don't include it on the bottom. We just include our 3 off targets. Okay. So it's going to look like, remember, so this is primary. This was FGFR2C. And on the bottom we have 1 molar, again we let them all be 1, over 1 plus 1.4 times 10 to the negative 7th over 10 to the negative 7th plus. This was FGFR receptor 1, see? 1 divided by 1 plus 1.6 times 10 to the negative 7th over 10 to the negative 7th. This is for FGFR 2B. This is 1 plus 2.3 times 10 to the negative 7 over 10. And this is for the third receptor. So if you plug all of this into your calculator and do the math, you should get 0.47, or really low specificity. FGF1 binds many targets. Okay. And then if you repeat the process for FGF5, top's going to look the same except for the KD is different for the FGF5 column, or it's a row actually. 5.2 times 10 to the negative 7th all over 10 to the negative 7th. And the bottom, all of the other ones were non-detectable, okay? So we have 1 over 1 plus, we said to use 10 to the negative 4th as the KD when we have ND or non-detectable, okay? Over 10 to the negative 7th, okay? Times 3, all of our off-target receptors were the same. None of them were binding at a detectable level. If you plug this in, you should get 54, okay? So sort of a way to interpret this is that FGF5 is more than 50 times more likely to be bound to FGF2RC receptor than all other receptors combined. Okay? It is much, much, much more likely to be bound to its primary target than to any of the other targets. Okay? So FGF5 is 50 times more likely to be bound to FGFR2C than all other receptors combined. And then actual, like in vivo specificity is even higher because all of the concentrations of the receptors are actually not the same. And so some of the affinities also actually do change. Some are even higher than 10 to the negative 4th. They're not detectable such that we let it be 10 to the negative 4th. It's an even higher number. And then these concentrations aren't all going to be 1 molar. So the real number is even bigger than that.